So we've talked about quadratic functions and polynomial functions already, and linear functions in 2-1. Today we're going to talk about power functions, and we're going to start talking about variation. We're going to talk about what a monomial function is and what the graph looks like. And we're going to talk about some just general characteristics of power functions. Tomorrow in class, we're going to talk more about what kind of situations are modeled with power functions, and then more about direct and inverse variation. I'll hit on it today, but we're not going to do any problem solving with those things. Okay, so first of all, trying to find my notes. Let's take a look at the definition. So a power function is any function that can be written of the form f of x equals k times x to the a. But it's important to note what k and a are. K and a are non-zero constants. Does it say anything about being integers? So a few days ago when we talked about the word polynomial, do you kind of remember that? We said to be a polynomial, there had to be integer powers. For it to be a power function, it does not have to be like that, okay? It can be any non-zero number. So you're going to see some fractions today as powers. Those are still considered power functions. K, which is the number in front, is called the constant. All right. Constant A is the power, and the K is the constant. A variation. Yeah. Let's take a look at this one. Can you see that? What root is that? 4. Do you know what we call that? So if we call a little 2 the square root, and we call the little 3 the cubed root, what do you think we call the little 4? The fourth root. No? What were you going to say? A little 5 is the 5th root. A little 6 would be the 6th root. When you have a little number outside the root there, they work the same way as roots do. And you've learned this before, but let's refresh our memory. The reason why the square root of 25 is 5 is because 5 squared is 25. Alright, what's the cubed root of 8? 2, because 2 cubed is 8. Agreed? Okay. What if I said then, what's the 4th root of... Oh gosh, I gotta do one. You're gonna know in a second. What's the 4th root of 625? 5. Because, check out 5 to the 4th power. So a 4th root undoes something to the 4th. A cubed root undoes something cubed, right? A square root undoes something squared. Now, here's the other thing that you learned about these roots. And again, I'm not saying you remember it, but you did learn it. The 4th root of x, if I wanted to rewrite it as a power, is x to the 1/4 power. If that's true, how would I rewrite the square root of x then? X to the 1/2 power. If you don't believe me, let me just show you graphically. We all should know at this point what the square root curve looks like. Agreed? Okay. Oopsies, not like that. Okay, watch what happens when I put x to the 1/2 in. I'm telling you they're the same thing. It's the same thing. This would be called in exponential form, because I'm writing it as an exponent. We call this radical form, because you're writing it as a radical. Okay. All right, well, moving on. If remember here I said k, that number in front was the constant of variation. Well, what's in front of this? 1. What's the power? One-fourth. Okay. Now I want you to kind of look at this a minute. This is the square root, right? I'm going to put the 1/4 root in and see if it looks kind of familiar. Doesn't it kind of look like the square root a little bit? Yeah. Let's sketch a little picture because I asked you to graph it. What's the, if I put 0 in, what's the 4th root of 0? 0. What's another easy point? 1. Because what happens when you multiply 1 times 1 times 1 times 1 times 1 times 1? It's going to be what? 1. Okay, so what's the 4th root of 1 then? 1. Let's find one more point, and I'm going to cheat. I'm going to go 2 to the 4th, which is 16. So that means the 4th root of 16 is 2, agreed? So I'm going to graph the point way down here, 16, 2. So it looks similar to a square root curve, but it's growing very, 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 very slowly. Very, very, very slowly. So this is f of x equals the 4th root of x. I wonder what a 6th root would look like. So I'm going to go ahead and put the square root back up there. There's the square root. Do you see how the square root grows a little bit faster? Okay. Let's see what's going to happen with the 6th root. Ooh. Kind of similar looking, but do you see it grow slower even yet? Which hopefully makes sense, because aren't 6th roots reversing the 6th power, so they're going to be pretty small when I output their values. Okay, interesting. So, just want to kind of give you a heads up there. In this case, we don't see it end up over here at all. And here's why. Remember how you can't take the square root of a negative number? You can't take the 4th root of a negative number either, or the 6th root. Because what you're doing is you're undoing an even power. And when I raise things to even powers, aren't they always outputting positive things? So that's why with these reciprocal, I'll call them, powers, the same kind of idea. Cool. So that's a power function. Here's another power function. Just because I said they could be fractions. I don't know. Give me a fraction. Like a fraction with numerator and denominator less than 10. She said to the 2/5 power. Okay. Now I'll explain what's going on with this function. The number on top means you're raising it to a power. So I'm squaring things, and then I'm taking the 5th root of them. That's what's going on here. That's what a fraction power is. So I'm squaring things and taking the 5th root of them. And then they end up being these interesting kind of graphs. Let's see this one. Ooh, by the way, can you take 5th roots of negative numbers? You can, but what happens when you square a number? Yeah, so since I'm squaring the numbers, they're going to become positive and take the 5th root. So I can have negative and x's, but they're going to always output positive answers. See? It's like this kind of curve thing. Yeah. All right. Let's move on to a monomial function, because this is a little different. But wait, it looks like the same thing. Okay, first of all, this is a monomial f of x equals k, so that means f of x equals 7. That's actually a monomial function, It's like 7 times x to the 0 power. That's what it means. Or f of x equals k times x to the n. And here's the deal, though. To be a monomial is a polynomial. These have to be positive integers. So monomials are a specific type of power function. They are a power function that has a positive integer exponent. Okay? Going back, then. This is a power function. Is it a monomial? No. Why not? This is not an integer. The power is a fraction, right? Okay. Cool. So, here is an example of a monomial, 3x cubed. So what monomial of same power is it related to that's a basic function? Good. I'll say it's related to g of x equals x cubed. In the air, if you're comfortable, would you draw a picture of x cubed? Okay. How does that 3 in front change the graph? Some of you are going like this. Vertically stretched by 3. All right, so just for the heck of it, I am going to graph. I didn't ask you in this example tube. There's x cubed, I'm going to put in y1. Then 3x cubed, I'm going to put in y2. And you can see hopefully what happens. There's x cubed. Yep, just stretched it vertically by 3. All right. So some other monomial functions that are power functions as well would be x to the 5th. I wonder what x to the 5th looks like. Ah, that's weird. What does it kind of look like? Doesn't it kind of look like x cubed? Are you like just is that like a tired nod or not getting a nod? A tired nod. How about x to the 7th? Ooh, doesn't that also look kind of like x cubed? How about x to the 9th? Okay, let's make a little generalization then. If it is an odd monomial function, what quadrants does it show up in? 1 and 3. What if I change to the coefficient to be a negative number? Then it would go to 2 and 4. Okay, just throwing that out there. I'm going to just show you this. We're going to study this more actually on Wednesday. I think you've seen this before. What does x to the 4th kind of look like? Kind of looks like x squared. What do you think x to the 6th is going to kind of look like? Okay, so even-powered functions look like x squared, and they end up being in quadrants 1 and 2. Unless the number in front is negative, then they would end up being in 3 and 4. Is that kind of making sense? Okay, cool. Then, let's see if we can sort through this. This is a general graph of some power functions. First of all, I'm going to talk about this. This is all power functions, monomials and ones that have integer powers. 3 things can happen when x is negative. One thing is x can be undefined. When did that happen? Give me an example when that happened. Fourth root, right? Or any even root, really. Right? We can't take square roots of negative numbers? Okay. When it's even, when it was an even power, right? And when it was odd, when it was a odd power? No? Are you seeing that? Yeah. Wasn't it odd? Okay. Now, I don't know if you remember when we first introduced even and odd, and I told you, please don't only think the only things that are even-powered functions. They're even-powered functions are even if they're monomials, but didn't we learn some other things were even too, like cosine and okay. Then here's what's going to happen. Here is when the power is 1. Well, why does it look like? What's that look like that I just highlighted? That looks like a line. What would happen if you put 1 in for A? You'd get K times X. Isn't that a line? Yes, it is. That's the line there. Okay. When you start putting in powers bigger than 1, do you see how they increase faster than that line? When you start putting in, they could be fraction powers. Remember our square roots and stuff? Then they increase slower. When they're negative powers, they become like the 1 over x function. Remember the 1 over x function? Yeah. This guy? Did you know this? That's really the same as x to the negative first. It's really a negative power function. So, all right, what happened here? What do you think happened in all these graphs for B? The K in front became negative, and so it flips it over. So this is kind of the reverse in the negative. If it was a negative something times x, then the line comes down here. If the power is greater than 1, it's like decreasing at a faster rate. All right. Now, that being said, we're going to try to do some in our heads, and then I'm going to have us look at the calculator and graph them too, okay? Okay, so here's what we're going to do. We're going to try to figure out what K and A are, the power, and then we're going to describe the portion of the curve that lies in quadrant 1 or 4. And then we're going to determine if f is even, odd, or undefined. Here we go. 2x to the negative third actually is the same as this. What does that kind of look like? 1 over x in your head. Think about what 1 over x looks like, okay? What quadrant is 1 over x in? 1 and 3. So 2 over x cubed, because this is still positive, is going to be in those quadrants. Okay, so is it in quadrant 1? It is. So I'm going to write in quadrant 1, when x is greater than 0. And how about this? When x is less than 0, is it an even function, is it an odd function, or is it undefined? It doesn't show up. If you need your calculator to help, you can. It does exist when x is negative. Does it look even or odd? This function. Okay, come on, guys. Does it look even or odd? Even? Is it reflected over the x-axis? No. Odd. What does odd look like? Rotation symmetry. Doesn't that look like it has rotation symmetry? Okay. So, when x is less than 0, it is odd. Let's take a look at the next one. So first of all, I have a negative number in front. I'm going to rewrite this as negative 0.4 x to the 3/2 power. Okay. So let me tell you what's going on. What's happening is you're taking the square root of something and then you're cubing it. Okay? When you take the square root of something, what's going to happen when that number is negative? It's going to be what? Try to take the square root of a negative number, people. You can't. What does that mean? You pick one of those three words for me? Undefined. Okay. So, in a second I'll talk about the quadrants, but when x is negative, this is going to be undefined. Okay. So you're telling me that this is going to output positive things, correct, normally? Because if I take the square root of something and it's going to be positive, what happens when you cube it? It's going to still be positive. But then I put this negative 0.4 in front. What quadrant is this going to be in? Should be in quadrant 4. It was in quadrant 1. When you put a negative number in front, doesn't it flip it over? So now it's going to be in quadrant 4 when x is positive. Would you take a look and confirm that on the graph? All right, let's try the next one. I don't think 0.4 is going to help me. I need to write it as a fraction. 0.4 is the same as what? Charlie Comeray knows this. We just did this for homework the other night. And Charlie Comeray is in 5th grade. And he's not a math genius. It's 4/10, which is 2/5. Thank you, Connor.
He said it like 5 times.
I know you did. I was just mad. All right, 2/5. So I'm going to take the 5th root of something. Ooh, can I take the 5th root of a negative number? I sure can, but then I'm going to square it. So it's going to be positive. So normally these things would show up in the top, like quadrants 1 and 2. But then I put a negative number in front. So then it's going to go from 1 and 2 down to 3 and 4. Okay. What do you think about this one? Because I have both, I have an even number and an odd number in there. Well, here's your hint. If it's showing up in quadrants 3 and 4, and I already told you it's not undefined because we can put in negative numbers. We can take 5th roots of negative numbers. If it's in quadrants 3 and 4, is that going to have reflection symmetry or rotation symmetry? Reflection. Let's just look to confirm. So I showed you something similar to before. Some of you said, oh, absolute value. It's not. It's got curves to it, but it's like this kind of cuspy looking thing. Maybe like a bird. That's how I would draw a bird because I don't draw very well. All right, here we go. So when x is positive, when x is greater than 0, it's in quadrant 4. And when x is negative, that makes the function even. Okay. I understand that that is really a lot to think through and I'm just trying to talk it out with you so you're thinking about what kinds of numbers, but yes, you can use your graphing calculator to help when you're looking at them. Okay. When x is less than, sorry, Katie, when x is less than 0, f is even. Okay. All right. So hold on a second.